Assalamualaikum warahmatullahi wabarakatuh. So, this is topic 1, AC circuit, but we go for the last subtopic of this topic, which is a three-phase circuit. But under this subtopic, we divide this under two sections, which is this one, which is balanced three-phase systems. And after we have finished this, we will go for what we call unbalanced three-phase systems. So in three-phase system, there are two connections. Okay, so the source and the load can be connected in either two configurations, whether in what we call Y connection, or sometimes also we call star connection, and the second one is delta connection. Okay, so this is the learning outcome. So after completing this lesson, you should able to actually understand what is actually the three-phase circuit. You should know the relationship between the phase parameters and line parameters. You can also able to differentiate parameters in Y connection and delta connection, and analyze or do some calculation on the three-phase balance systems. So just a revision. So actually what we have learned is actually the first one, we have already learned about what we call active power, or sometimes also we call average power. So it can be written either in a VMIM term, or you can also write down in term VRMS and IRMS term. And you should know also that the power factor is actually related to this function cos theta b minus theta I, and this theta b minus theta I is also can be related to what we call the impedance of the load impedance. Okay, the angle of the load impedance, or theta z. And the average power also can be written either in this form. Okay, so as you can see, there is no angle here. So this is actually only the magnitude involved, and also here. Okay, and also you can, we have also studied about what we call the reactive power. And this reactive power can be either positive. So positive meaning that this is inductive. Always please be reminded that positive is negative is actually a capacitive. So if it is inductive, meaning that your power factor is lagging, and for the capacitive, your power factor will be a leading power factor. Okay, and you can also write down the Q in terms of XL and IRMS. Okay, so this is only magnitude. Okay, so you can write down like this, or for the QC is like this. So please remember that for QC, the value is always negative. And we have also studied about the power triangle, the relationship between the what we call the reactive power and active power. And this S is what we call apparent power, where apparent power is actually okay, so apparent power is actually the summation of P and Q in the complex form. Okay, so actually we have complex power here, which is also X, so it's actually an apparent power with an angle of theta B minus theta I, where if we expand this, we can actually got P plus minus JQ. So plus minus meaning that it depends on the type of load that you actually connected. Okay, and we have also studied on the conservation of AC power. So you should know that regardless of connection type, whether it is parallel or series, the summation of all power should be absorbed by the load or inside the circuit is equal to the power that supplied from the source. Okay, so that is actually for all the AC power single phase. So now what is what you call a three-phase circuit? So it is a system produced by a generator consisting of three sources, AC sources, which having same amplitude and frequency output. Okay, so both three of them have same amplitude and same frequency, but the phase is actually different to each other by 120 degrees. Okay, and as you can see here, we have this type of connection, and you can see here we have phase A. This one we call phase A, phase B, and phase C. Okay, and then we have what we call a neutral line here. So sometimes because usually if you have this type of configuration, so sometimes we call this one is a three-phase four-wire system. Okay, three-phase four-wire system. Okay, so why do we sometimes is also don't have neutral cable. Okay, so it's actually depend on the your circuit configurations. Sometimes there is no neutral cable, but sometimes we need the neutral cable. Okay, so advantage of the three-phase system. So why we have a three-phase system? We need to consider three-phase because most of the electrical power is generated and distributed in three-phase system. And the second one is that the instantaneous power in a three-phase system is almost constant. Okay, and the amount of power in the three-phase system is more economical compared to the single phase. Okay, and then in fact, actually the amount of wire required for three-phase system is less than required for equivalent single-phase system. And this is actually how we generate. So actually we have a AC machine here, AC generator. So we have a stator, and this is actually the part which is stationary. Okay, and then we have a rotor. So this rotor is actually turned by the turbine. So maybe the hydroelectric, so or maybe the steam. So it will due to the steam, it will actually rotate the turbine, rotate the rotor here. Okay, rotate the rotor, and due to the flux cutting and so on, so it will induce voltage and current. So the induction of the voltage and current will be in a AC form, which is has a magnitude of same magnitude, same frequency, but different phase. Okay, so we have phase A, phase B, and phase C, but all of them are actually out of phase 120 degrees. And this is the three-phase configurations. So the source and the load can be connected either in two possible configurations. So which is this one we call Y connected, or sometimes we call star. And the second one is actually delta, or okay, delta connected, star, or sometimes also Y. Okay. Okay. So for this one, so as you can see, this VAN and VBN and VCN here, where VAN is actually a voltage from A to N, VBN is from B to N, and VCN is from C to N. Okay, so this is called phase voltage. Okay, while for if you VAB, for example, VAB, this is from A to B, and then you have also VAB, VBC, and VCA. Okay, so VAB, VBC is actually from VB to C, and from C to A. Okay, so this one we call line voltage. Okay, and we have also what we call current. Okay, so this one is IA, IB, and IC. So IA, IB, IC is referred as a line current. Okay, and we have also, if we have current that flow from A to B, which is we call IAB, also VAB, VBC. Okay, so from B to C and C to A. Okay, here. So this one, IAB, IBC, and ICA is called as a phase current. Okay. So since we have either Y and delta, so the connection between source and load can be found in four possible connection between source and the load. So the first one is the source is connected in Y and also the load is Y. So Y connection, we have Y delta connection. So this is more towards what we call the step down. Okay, the voltage is step down. And we have also delta to delta connection and delta to Y connection. Okay, so this figure shows two of the connections. So Y connection. So as you can see here, the source is connected in Y and the load is also connected in Y. Okay, usually for Y connection, we have what we call the neutral cable. Okay, so this one we call Y to Y connection, but actually a three-phase four-wire systems. Okay, and we have also, please note and highlight that the connection, okay, we have B is connected to the phase B, to the B, point B, and C is connected to the point C. While as you can see here, the second one is the Y to delta connection. Okay, so Y to delta connection, and as you can see here, since we have delta, so it's not possible to have what we call neutral cable connected between source to the load. And the third connection is delta to delta connection, and also the fourth connection, which is the delta to Y connection. So a balanced three-phase system is, we should know that it is actually, we have three voltage source that are same in magnitude, same in frequency, but out of phase of 120 degrees for all phase. So that is what we call a balanced three-phase voltage. Okay, and for this three-phase system, we have two-phase sequence. So we have what we call the positive sequence and negative sequence. You should know already that for the phasor plot, we assume that the phasor is always rotating anti-clockwise. Okay, so if you put your eye here, you should note that we can actually, you see the phase A first, and then we'll come for phase B, and then next is C. So if you have this type of sequence, so this is what we call a positive sequence. Okay, and if you have like this, you put your eyes here, so you see the A and then C. and B. So this one is actually negative. So anything that is not A, B, C, so we call negative. Even though you have if you have like this, B, A, C, so still this one is also a negative sequence. Okay, so only the positive sequence if you have A, B, C. Okay, so this is the phase angle here. So BA usually we put as a reference, and VB usually as you can see, uh, due to the reference of BA, so this one is a negative 120 degrees, and BC is from here is actually a positive 120 degrees. Or you can also write down BC as negative 240 degrees. Okay, so either one is okay, but usually we use use this one as for the VC. So can you determine example one? Can you determine the phase sequence of this set of voltage? Okay, so the answer will be discussed during our class. Okay, so this is still the balanced three-phase voltage, which I have already mentioned earlier. And so we have a balanced voltage source, and a balanced load is actually one. This one is also very important. A balanced load is one in which the phase impedance are equal in magnitude and in phase. So meaning that if you have like this, Z1, theta 1, so and then you have another impedance Z2, and then you have another impedance which is Z3. So for a balanced load, meaning that Z1 is equal to Z2 is equal to Z3, meaning that the magnitude, meaning that the value of the impedance are balanced in all systems. So that's why it's called a balanced load. So this is the interesting part in this subtopic, which is the relationship between line and phase current and voltage. So please be noted that we have four for the current. So we have what we call line current. Usually we refer as IAB, IBC, and ICA, and we have also phase current, which is we refer as IAB, IBC, and ICA. Okay, and we have also voltage. So for line voltage is actually VAB, VBC, and VCA. And for the phase voltage is VAN, VBN, and VCN. Okay, so that is for your informations. Okay, so for Y connection, okay, so Y connection, so VAN is your V phase, okay, and VBN and VCN, but all should be 120 degrees different. So this one. Okay, and while VAB, as I mentioned earlier, is your is your line voltage. So this is actually VAB, meaning that from this point, this terminal to terminal B. So this is your VAB, and you can actually calculate VAB by using VAN minus VBN. And we know that VAN is this one, okay, and VBN is B phase with an angle of negative 120 degrees. And if you convert into a complex numbers in the rectangular form, you should obtain that V line, okay, VAB is actually VAB, which is your V line, is square root 3 multiplied with B phase with an angle of 30 degrees. And the same thing you can actually do to obtain VBC and VCA. So this is your VBC and this is your VCA. So in general, after we observe the relationship between this VAB, VBC, and VCA in terms of their connection with the what we call the phase, we finally can summarize that V line voltage is actually has higher value of voltage, where you can see it is is a square root 3 unit multiply with the V phase, and it has what we call a positive 30, meaning that it has a positive 30 degrees from the different from the uh, phase voltage. Okay. And also, I would like to share with you. Share with you on the V phase and also the V line. Okay, so to make you understand more. Okay, so let's plot the phase. Okay, so we assume that this is your V phase, which is so I think we just put it as a VAN with an angle of 0, and then we have what we call this one is VBN, so the angle is a negative 120 degrees, and then we have another one which is VCN, so this one negative 120 degrees, so this one is positive 120 degrees. Okay, so this is also 120 degrees. So VAN, VBN, and VCN are V phase. Okay, and VAB is actually VAN minus VBN. So we have know that VAN with an angle of 0 minus VBN with an angle of negative 120 degrees. You should get that your VAB is square root 3, and since we know that VAN is VBN and is actually VCN, so we can actually just put VAN with an angle of 30 degrees. Meaning that if you see the VAN minus VBN, if you can actually plot in a vector, okay, in a vector. So this is positive VAN. So negative VBN, if you plot, is actually a vector here. This one is negative VBN. Okay. Okay, so when you plot the vector VAN minus VBN, you should get the total vector, which is paduan vector. Okay, so which is this one is actually VAB, and the angle of VAB here is positive 30 degrees. Okay. So the same thing happened. So for the VBC also, so you should have that your VBC is actually this one with an angle of positive 30 also, but from here you can see that the angle will become a negative 90 degrees. Okay, this one negative 90 degrees. Okay, and the same case also for VCN, where for VCA. Okay, so for VCA you will have this with an angle of 30 degrees. So your VCA okay, with an angle of 30 degrees, meaning that this one is 150 degrees. Okay, 120 plus 30. So in general, your V line is actually for all A, B, C is actually is actually a square root 3 multiplied with the V face, and the angle is actually 30 degrees plus 30 degrees. Okay, so I hope you understand on the relationship between V line and also I line. So we go back here. So this is the summary. So if you do confuse, you can actually always refer to the summary. Okay, and please also be noted that for Y connection, the I face is your I line. Okay, why? Because as you can see, your I line is IA, and the same current IA is actually flow inside your element here. Okay, so I line is I phase for Y connection. And let's look at delta connection. So for delta connection, okay, the same case also happen. You can actually derive the relationship between the line current and phase current. Okay, so in summary, so as you can see here, the I line is square root 3 multiply with the I phase, but the angle need to be negative 30 degrees. And please be noted that I line is always write down as IA, IB, and IC, while I phase is IAB, IBC, and ICA. Okay, so but for this delta connection, please be noted that V phase is your V line. Okay, so it's quite different for Y connection. The I phase is I line, but for the delta connection, V phase is B line. Okay. So you should know already the relationship between voltage, okay, phase voltage, phase line voltage, phase current, and also the line current. And you should know for the Y connection, I phase is your I line, and for the delta connection, B phase is your V line. And this Y connection, this for Y connection, so the relationship between V line and also B phase can be found as in this box. And for the delta connection, the I phase and I line connection, or in the what they call the relationship, can be found in this block. So we go for example 2 and example 3, where I would be like to discuss it during our class. Another slide before we end this subtopic is that for a Y connection, three-phase Y-wire system, okay, this line cable, if the load is actually just for what I call the uh, protection step. So if the load is unbalanced, so if the load is unbalanced, okay, there is a what it calls imbalance current that will actually flow inside this neutral cable. If the load is balanced, there is no current that will flow through the line cable. Okay, and then so this is for the Y delta connections. No, actually no neutral cable, and we will go for example 4, 5, and 6 in our next class. Also for this example 7. Also example 8. Okay, so thank you very much for your attention. So I think we finish on the topic 1, AC power, and next we will go for the topic 2, which is a very interesting part in this subject, which is the magnetic circuit. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.